Hi everyone, I'm Alan and this is a new episode of the Intelligence Podcast. In this episode, we are again going to talk about longevity. And for that, I invited Keith Comito, the president of the Life Extension Advocacy Foundation, or LEAF. Keith is a renowned voice in the field of aging and longevity research through his leadership of the Lifespan.io initiative. Keith is a mathematician and a computer programmer. Through his career, he helped write many software solutions and metaverse-related technologies that were adopted by major tech companies. And I think that coming from this background as an engineer, Keith has this unique point of view on how to attack on problems related to longevity research and how to integrate emerging technologies to help advance the healthcare field. With Lifespan.io, he built a very comprehensive all-in-one platform where everyone, like yourself, can go and get educated about the field of aging, longevity research, the different technical problems that the field encounters, and the different companies that are working on those problems. You can also know more on how to contribute to the field through YouTube videos, blog posts, conferences, raise funding events, and so many other ways. Throughout this chat, I asked Keith about the most recent advances and the most difficult problems the field of longevity research is currently facing. I also asked him about the contribution of AI, of gaming, and of the blockchain technologies and the potential they have in transforming the field. We talked about the social impact of lifespan extension and also about how people watching this video can contribute to its advancement. Finally, I hope you enjoy this interview. And as always, if you enjoy this content, the best way you can help is to subscribe. Thank you for watching. Keith Comito, thank you very much for joining me. It's a real pleasure to have you on this discussion.
Thanks for having me. Happy to be here.
Thank you. So let's actually start by talking a little bit about the future of longevity as you see it from your perspective. I know you are involved in many of the efforts in that sphere. So I would like to try to give some, say, predictions in a way, or expectations. So do you think that the generation or the people alive today are going to live significantly longer?
Yeah, obviously you can get into trouble if you're too speculative with questions like this, but to give you my personal sense of it, is I guess I can say that I'm optimistic for people who are, in my age bracket, I'm in my mid-40s right now and younger, that, I think it's looking good. But I think the important point is that any kind of maximal life expectancy increase is going to be bootstrapped. It's not going to be something that happens overnight. There's not going to be some magic pill when you suddenly take it. Now you're going to be 20 years longer. I think the therapies that we're seeing emerge now might have very marginal effects on your life expectancy, on your health span, but that might buy us more time for scientists to figure out the next thing and, longevity, escape velocity, and all that. So again, I don't want to make any too precise predictions because I don't think we know enough, but I'm optimistic that, if society properly prioritizes this issue, which I believe it should, and we allocate the resources necessary, I think we're on the path now to making progress at an increasing pace. So I'm optimistic, I guess I can say.
Okay, so let's say this is a positive sign in the right direction to being optimistic about this. But you mentioned that you think that most of the efforts today will have minor effect on the health or lifespan. So does it come from the fact that we do not understand aging, why this will be minor actually?
For me, I actually, again, I'm optimistic that our understanding of aging is proceeding apace, and that thanks in part to having frameworks of understanding like the hallmarks of aging that are, of course, being iterated on. I think why I had stated that I think the first gains will be marginal is more just in a sense of the required engineering complexity, right? So by that, I mean the types of therapies that I think we'll see having an effect in the short term are based on, nutraceuticals and things like that already exist, things like NMN or Metformin, And so the engineering complexity is low because these things exist right now. But I think that they will have like a marginal effect in terms, because we're not systemically re-engineering ourselves in the same way that if you wanted to go into the other far extreme, in a future where you might have like nanomachines coursing through your blood that are like re-engineering things. I think that's much further off, on the technology spectrum. But obviously, if we had those powers, the gains could be much more significant. So for me, it's just a question of engineering complexity and like where we are on the spectrum right now. Does that make sense?
Sure, yeah. Yeah, so we will come to this, let's say, comparison between, not like deep comparison, but between supplements or medicine versus biotechnology, like intervention, really like deep interventions to fight against aging. But let's start really from some basics. You mentioned the hallmarks of aging, and you also mentioned that we are iterating on them. So can you just like quickly mention what are, like, in few words, what are these hallmarks? And when you say iterating, does that mean that they are being changed, updated, or what's happening here?
So again, like one of the major, I guess you could say, conceptual breakthroughs that have happened in the past, 20 years or so is this emerging idea of the hallmarks of aging. And it's gone through a couple of different iterations. Sometimes it might be known by other names, but the basic idea is this, is that even though the kinds of diseases that you might develop through your life, the pathologies that can go wrong with you are myriad, right? If you kind of look at it in terms of like a spectrum of damage accumulation, there really is only a relatively limited subset of things that break in you, types of damage, junk inside your cells, junk between your cells, DNA damage, things like this. And these and combinations of them are what causes all the pathologies. So the framework is, if we can identify what these classes of damage are, those are the areas that if we can figure out how to remediate those damages, we can prevent all of the myriad pathologies. So to give you some examples of what are, part of the canonical hallmarks of aging might be things like, genetic instability or, epigenetic changes, loss of proteostasis, mitochondrial dysfunction, things like this. And speaking to the question that you just had in terms of, what's being iterated upon, is that there is some debate right now of, is it 10 types of things? Is it 12? Are these two really the same type of thing? And there's some like nomenclature iterations going on there. But I actually take that as a good sign that if those are the kinds of conversations we're having now, those are much more kind of precise conversations than the conversations that we were having 20 years ago. So, it's iterating on this framework of like, what are the discrete types of damage and how can we address those types of damage?
Yeah, so as I said, like these are, let's say, maybe a way of quantifying maybe a continuous spectrum of, let's say, maybe damage types. So we are trying to just simplify the problem. But how does it go actually? Like, can we gain or have small wins if we attack one type of these damages at a time, or we really need to attack on all of them at the same time? How does that happen actually?
Yeah, that's a very good question. And I think the answer is a little bit of both in that, and I don't want to be too like hedging in my answer, but I think that there are some areas like in senescent cells, for example, where if we can solve that problem, this is the idea of kind of building up these like zombie-like cells that you accrue in your life. If we can ablate them, if we can clean those out, essentially, I do think that one, if we solve that one hallmark completely, it would probably give non-negligible increases of lifespan. But if we're ever really going to push, like not on the 10, 15%, but like double or something like that, then I think you really need an all of the above strategy, because it's literally, just like with evolution, right? Like the reason why we're probably not engineered to live 5,000 years is because something was going to kill us first. And there was no evolutionary incentive for us to be optimized to live 500 years, because on average, something else is going to kill us. So if you just take that and apply it to the hallmarks of aging, right? Even if we solved, I'm just making this up right now, even if we solved every other type of organ damage, but we didn't figure out how to solve brain aging, well, then it doesn't matter, because at 120 years old, you're still going to die. You're still going to have dementia, because that one issue is more than enough to completely wreck you, right? So you're going to need an all of the above strategy. And that's why I'm happy now that we're starting to see some projects that are not only looking at just like one therapy, but projects that are trying to attack like combinations of the hallmarks of aging, so that, as we do those experiments, you start to get a sense then kind of mathematically, combinatorially, of like, where could the most gains happen? Which combinations will be the most effective for us to focus on right now to buy us the maximal amount of time to figure out the other things. So it sort of becomes like a mathematics combinatorial game in a sense.
But this actually seems kind of course, like as a difficult problem. But when I try to imagine how it looks like for researcher, let's say, so there are these hallmarks and there are, of course, let's say, interactions between them. So if or like, let's say, a company or researchers developing like a solution to one of them, how would we be able to test if this actually gives some wins or not? Like, how do we measure the gains in aging?
Yeah, so I think this is kind of where the subject of biomarkers becomes increasingly important. This idea of being able to have proxy measurements for aging or aspects of aging. One that's very well known right now is the epigenetic clocks, like the Horvath clock, which is looking at that kind of one proxy aspect of aging, changes that happen to your epigenetics. So I think, as we have more different kinds of biomarkers that can track aging, I personally have worked on some that are on like the physiological side, like literally like how you look and your voice sounds and things like that, that can be signals for changes that are happening inside the body. I think that's one area where we'll be able to see if we're having partial effects or effects. Another area is that in looking at how the confluence of these aging therapies can also be used for other indications where there might be something more immediate that can be seen. As an example, I had mentioned senescent cells before, right? These zombie cells, right? So in addition to just being a byproduct of, quote unquote, normal aging, senescent cells can arise due to other insults to the body, right? Things like chemotherapy can cause senescent cells. So as an example of something where you might be able to see a result is, well, if you paired chemotherapy with a senolytic therapy to mitigate the senescent side effect of chemotherapy, if the hypotheses are correct, and I'm sure there's been some studies to this effect. And again, I'm not a molecular biologist myself, so, audience can go look at the work here. But my point is, if you were to see that there was a rescue of the negative effects of chemotherapy by pairing it with senolytic therapy, that one would kind of prove, that you're on the right track with senolytics in general. But then also, if you're making the extrapolation that the insults of chemotherapy were a rapid fire version of what happens in normal, quote unquote, aging, then that's a good sign for its effect on aging. Does that make sense?
Yes, yeah. So as I understand it, so it's kind of these, let's say, hallmarks or the damage types, they cause some phenotypes, not only like aging, but there are also other phenotypes. So we can measure these phenotypes before we measure how the person will live eventually.
Right.
Okay.
And, yeah.
Right. So in terms of different families and kinds of solutions, so this one, for instance, we talked about senescent cells, but I also hear about changes, like solutions in terms of changes to lifestyle, like doing sports or also supplements, medicine. And there's also the intervention like biotech and other more advanced methods. So how do you see all of these families? Are they trying to solve the same hallmarks, or like what are how they work actually?
Yeah, I'm glad you asked me this question, because people are always curious of like, what can I do right now, for health? And, to answer your question, the best things that you can do right now, like lifestyle wise, are the things that your parents always told you to do, right? Sleep well, super important, eat in moderation and keep stress low, have a good social life. That's very important. And, love life, have a good mindset. It sounds a little cliche, but these things actually matter. And one thing that I like about the fact that this turns out to be effective is it creates a nice commonality or a through line between, say, like Western and Eastern, like medicinal thinking, right? So as an example, through what we just talked about, it's been many moons since I did this as like a profession, but I used to teach yoga, back in the day, and study martial arts. And, there was a period, and, there's some aspects of certain practices that can still be a little bit pseudoscience-y, right? But there's also some aspects like, deep breathing, meditation. If that lowers your stress level, that will decrease your rate of inflammation, which is a driver of aging. So yes, you can actually affect some of these things by just making lifestyle changes. Now, important caveat there is that I don't think these lifestyle changes are obviously going to do anything to the maximal life expectancy, right? You're not going to suddenly live 300 years old if you're like an expert yoga practitioner, right? So I think it's more that lifestyle changes and modifications can be very significant on a per person level to help you achieve what is currently close to the maximum. But if we want any kind of maximal gains, then we're moving into, okay, now we need like serious, bioengineering and things like this.
I think many people are convinced that this kind of like best practices have an effect on their, let's say, health span or lifespan. But when we talk about longevity research, we are really talking about, let's say, a breakthrough or like a revolution in terms of the time humans will live. So in some cases, I feel it becomes a little bit frustrating if we like after when you listen to the media and about longevity research, etc., and then you just say, but the best thing you can do today is just to do sports. So it feels like, okay, but until when? Like, when are we going to be able to apply other solutions?
Yeah, that's a good question, and it's an important balance to strike, right? Which is you don't want to overhype, right? Because that happens so easily. Anytime there's any therapy or a trial that shows any kind of interesting results, you'll see the press is a fountain of youth discovered, guys, great, and then of course when that doesn't happen, then it builds up a lack of trust in the field. So you don't want to go in that direction. But on the other hand, to your point, you also want to paint some clear targets. You want to inspire people and say, hey, this is actually going to have an effect. We're getting closer, right? So you have to kind of strike that balance. So one of the ways that I usually kind of speak to this issue is like, because people are always asking for predictions and stuff, and I very am wary about giving anything specific because as a scientist, the major thing to keep in mind is like you never know, like who knows what's going to happen, right? So I hesitate to say anything like really precise, but I'm more comfortable in terms of like time frames and steps and like what's the likely roadmap. So to speak to that issue, I think. Right now, I think the best things you can do are those things, right? But emerging right now and over the next couple of years are the kind of things that we were speaking about earlier that, if metformin has been proven to show, if we do the TAME trial, to show a result, or things like NMN, the charity that I help run, Lifespan.io, is invested in this company I'm about to mention. So do your own due diligence here. But something that I take personally is this nutraceutical product called Novos, which is a combination of ingredients that are all like generally recognized as safe, things like AKG and glucosamine and things like this, NMN, and I think that likely, again, I hesitate to say it's proven yet because the studies are still forthcoming, but I imagine things like that might give you a few years on your life, on your health span, your lifespan, right? So I think that is emerging right now. So again, I don't want to shill or anything like that, but I would say in addition to sleeping well, exercising, you might want to investigate things like metformin, things like rapamycin, things like NMN that I do think would have now, things that you could get now that would have a marginal effect. What I think is coming in the next 5 years is things like senolytics becoming more operationalized in terms of how you can actually apply that. So maybe this is something like Fisetin that you should take in a pulse once a month. You take a lot to help clear out your senescent cells, something like that. Something like that, I think if it worked, would achieve a little bit more of a marginal effect, maybe 5 years on your health span, et cetera. And again, I'm just shooting from the hip here, and don't hold me to it. But my point is that I think that's the near term roadmap, and then further out, you have more of like the significant like bioengineering, re-architecting things like that. But there has been progress made in various hallmarks, things like mitochondrial dysfunction. The SENS Research Foundation has some good work there on like backing up the mitochondrial genome in the nuclear genome that might help stop mitochondrial dysfunction. And that's something that's crossing over into that realm of, okay, that's actually like re-engineering us a little bit, if we do something like that, right?
Yeah, I'm glad you're explaining this, because it really, this is how actually credibility also, in my opinion, is. Even when we like when we read an article about a drug supplement, well, this is the solution. We have it now. So you are explaining it in a very objective and, let's say, clear manner. These are going to be in steps. We have supplements, there are tests, and we are, let's say, waiting for results, and there are some indications. But these drugs, let's say Metformin, Rapamycin, etc., what hallmarks they are addressing? Are they also addressing like different things, or they are specialized in only one, let's say, type of damage?
Here's where I will defer to the actual biologist to get into more details, but I will say that, I think it's probably like your mileage may vary. For example, as far as I know, from my understanding, the things that I was just talking about are somewhat scoped to a subset of the hallmarks. When I think of NMN, I think of things like that addressing genetic instability, because, it helps to upregulate DNA repair mechanisms. When I think of Fisetin, I think of that as addressing senolytics and senescent cells. So that kind of hallmark specific. So as far as my understanding, the potential drugs that I had mentioned are kind of, are a little bit hallmark focused. And that's why I'm interested in things like seeing the birth of projects like Novos that have a combination aspect in their spirit. If you can combine these, this addresses that hallmark, this addresses that hallmark, then I imagine you'd have compounding results. And again, I don't want to say anything too strongly, because I'm not a molecular biologist myself.
Okay, so let's move a little bit to talk in more detail about your personal and also the contribution you are working on through Lifespan.io, the one you mentioned just earlier. So can you just tell us a little bit about the history, how you founded, and like why you founded this organization?
Sure. So Lifespan.io was officially founded back in 2014, and it came as an outgrowth of sort of some serendipitous meetings back in the day. So my background formerly is in computer programming and mathematics, and I've had a life as a technology inventor in addition to my work in aging that is starting to intersect. But around that time, let's say 2011 or so, I was reading some books that were coming out at the time, for example, Ending Aging by Aubrey de Grey. It was around that time. And, it made the case to me that, aging is a tractable engineering problem, right? I was a computer programmer, so it made sense to me as I read through it, like, we can work on this. It's not magic. And then out of that interest, I started to attend classes at the Citizen Science Lab called GenSpace in Brooklyn, which was famous and still, I think, somewhat famous as sort of being a pioneering, like first in kind citizen lab space where people who have no biology experience like me can just come in off the street and like actually, get a pipetter in your hand and start working on actual biotech projects. And it just so happened that one of the co-founders of GenSpace was Oliver Medvedik, a molecular biologist who earlier in his career was working in David Sinclair's lab back in the resveratrol days. So we, started talking about, aging. He was obviously interested in aging. I was interested in aging. And basically out of that kind of energy coalesced into this like nucleus of people in New York who were interested in driving this field forward. So we started to have some preliminary meetings. And then what we came to when we founded the charity was that what we saw as sort of one of the critical lacks at the time was basically in public perception, right? There were some labs out there that were starting to work on aging or had been working on aging for the past decade, doing some good work. But we saw that the gap was in public understanding, rallying support. So basically what our initial plan was essentially to emulate what the early cancer research advocates did in the 1940s, which is described beautifully in the book, The Emperor of All Maladies by Siddhartha Mukherjee, which is basically identify the credible research of the time, try to build public support behind it, doing things like crowdfunding. Back then, it was like things like telethons and the Jimmy Fund, right? Build up a grassroots movement. And then when you have that galvanized grassroots movement, you can make bigger things happen. In their case, it was basically causing the 1971 Cancer Act, the war on cancer, right? So what we did was we created a crowdfunding platform, started to raise funds for research projects like for SANS or for Harvard Medical, David Sinclair's work, as mentioned earlier. That went very well. We were the most successful scientific crowdfunding platform in terms of amount of dollars per project. Sometimes I think it was something like $45,000 average per project, where if you compared that to Kickstarter or Indiegogo for science projects, the average was 4,000 or something, right? And then we parlayed that into creating the most trafficked news outlet on the subject of aging, YouTube shows, doing collaborations with YouTube celebrities, appearances on the press, talking to, even on political shows, right and left wing, basically getting out there, rallying the public and having a lot of success with that. And, that is still continuing to this day, but I don't want to keep going in a run-on sentence, so I'll pause there and see if you have any follow-up questions.
Sure, yeah. I'm really interested about how do you see the difference in, let's say, public and also institution acceptance compared to that day. Did you see major progress, or it's still as difficult as that time? How do you see it?
I see it, thankfully. Don't get me wrong, a lot more work still needs to be done, right? But I think it is radically different from the way it was 10 years ago. I don't want to overstate and take too much credit for that for Lifespan.io, but I would like to think that we had, a good role in that. And just one moment that I would like to just kind of call out as sort of, at least in my mind, that seemed like a good, title change kind of moment, was even though now we have our own YouTube shows that have millions of subscribers like Life Noggin, back a decade ago, there really wasn't a lot of channels that had any kind of significant audience on, social media that were talking about this. And we had managed to collaborate with one of the largest channels on YouTube at the time called Kors Gesagt. They do fantastic, animations. You've probably seen some of their videos, right? And in 2017, after years of kind of whispering in the ears, we got an agreement to collaborate on a 2-part series on aging. And what was interesting about this series was it was very, reasonably presented, not crazy, but they chose in the subject, in the thumbnail, in the title, it was can we cure aging? Should we solve aging? It was very overt, right? And at that time, a lot of researchers were very, skittish about saying that we're actually working on aging. We have to dress it up. We have to say it's Alzheimer's disease. We have to say it's heart disease. And those videos, when they came out, they hit about 14 or 16 million people in the first couple of weeks, which at that time became the most seen videos on the entire internet for that week. And more importantly, was that the like to dislike ratio was 99.999 yes. And there were just tons of comments of basically yes, the public is ready for this. So I think that almost served as a watershed moment where when a lot of people in the research community and others kind of saw that, there was a recognition that, okay, as long as we present this in a not crazy way, there's potential public acceptance for this. So again, that's just one moment. I don't want to overstate it, but I've noticed that ever since then, and very particularly in the past few years, the conversation has shifted. It is no longer, this is crazy. Now it's all right, well, maybe it's possible, but should we do it? It's graduated to that next level of conversation where there's no longer this base level assumption that this is just off the table, right? I can give a lot of other examples like that, but basically short answer is that there's still a lot of work to be done, especially in terms of government funding being allocated and stuff. But in terms of the base level public understanding of like, is it possible to perhaps work on aging? I think it's much better now than it was 10 years ago.
But do you think that like this acceptance, let's say or like more acceptance, let's say, is really due to proper communication, like public communication, or there are other factors, let's say, coming from research labs that gave more credibility also to that?
Yeah, I think that the answer is both, and that they feed upon each other, right? You can only educate the public about something exciting and plausible if there's something exciting and plausible that exists. Otherwise, you're lying and doing the snake oil thing, which vis-a-vis the earlier part of the conversation will only come back and undercut whatever movement building you're trying to build, right? So they have to go hand in hand. It's only because the research has progressed that we're able to actually galvanize the public. But to answer your question, I do think narrative crafting is extremely important, because that's also what might sometimes, like, vertexes happen in history where like something will zig or zag, the stem cells will be banned or not, or like something like that. And like the background layer of how the public feels about something suddenly becomes very important in those moments, right? So I do think, if nothing else, that's where like the rubber like really hits the road there, is, what's the average sense of like, does the current administration think it would be a good move or a bad move to say that we're going to do a moonshot to try to cure cancer and Alzheimer's together by working on aging, as an example.
So yeah, from my personal perspective, I kind of perceived this from like say public point of view, because maybe 6 or 7 years ago, I started to discover about this field, and then now, like literally, the French media. I live in France, so the French media is also like talking about this. Podcasts are talking about this. My friends sometimes they just mentioned I listened to that or that podcast. So it's really interesting to see how to which extent when the idea becomes accepted by people, it kind of become normalized. So this really reached also to the scientific community. And as you mentioned, it's like cycle, like feedback loops. So coming back to work by Lifespan.io, I also discovered about the rejuvenation roadmap. So what's that roadmap is about actually?
Sure. Yeah, that's part of one of our like 3 main tentpoles of our current focus of initiatives, and this one being like educating and informing and exciting the public. So we wanted to create data visualizations that can make complex concepts like really simple to understand, at least at a base level, at a glance. So as an example, one of the first ones that we made, and we've made others now, is the rejuvenation roadmap, which basically takes that framework of the hallmarks of aging, lays out all the different projects that are working on those different aspects. So for genetic instability, maybe there's 5 projects listed. For telomere attrition, maybe there's 20 projects listed, etc. But then shows where each of those projects are in, say, the clinical trials process, phase 1, phase 2, phase 3, etc. And then if you click on any one, you can drill in to learn more about that specific project and where things are at. So what this allows is, number one, if you're just someone coming in who has like no knowledge about aging whatsoever, and you just read like a piece about, okay, hallmarks of aging, but great, like what's actually happening, you could see something like this and just at a glance just get a sense that like, oh, okay, like we're like knocking down some of these dominoes, or like, or if you're more part of the field, and looking to understand where the gaps are, you might be able to say, oh, we're really far along on this one hallmark, but like nothing is really being done on this hallmark. And our earlier conversation, we're going to have to hit all of them. So maybe if you're a new person coming into the field, you go, oh, okay, my background is concordant with that hallmark, and there's not a lot of work being done here. So maybe this is where the best value of my effort should go. I'm going to try to create a project to address that hallmark. So I think you can just say it as almost like mapping the space and helping to paint targets for future work. Does that make sense?
Yeah, sure. I really think it's a very useful visualization. So I'm just checking it out now. So the first time I went to that page, so it's on the lifespan.io/road dash maps, so the rejuvenation roadmap. So I just wanted to look at a column, that the released column, to see what are the solutions that are already there. So there are some of them that in the release column. So for instance, in epigenetic alteration, there is the tissue rejuvenation, or there are also others like in the lost proteostasis. So what does that mean when we say it's released? Does that mean there are solutions out there we can just go to the lab and apply it to ourselves?
Yeah, again, I'm sure its mileage may vary on a case by case basis. And if you drill into each of the projects, it'll tell you like, is this available? Where? What can you do? And also there's some of them where, like if it's for a nutraceutical that's generally recognized as safe or something like that, it might not even need to go through the phase 1, 2, 3 process. So hence it is available by default, things like that. And again, check. I would encourage anyone who's curious, lifespan.io/roadmap and drill into them. Something that we're adding, a little bit of inside alpha here, is we're going to make this animated soon, where we'll have a built-in history of sort of where each project was in the past, so that you can also get a sense by kind of like time lapsing it. Because seeing a static image like this doesn't necessarily tell you the full story, right? Maybe one of the hallmarks, has a lot of stuff in phase 2, and one of them has a lot in phase 1. So you might think that this one is much further along than that one, but maybe if you time lapse it, you see that this has been stuck for 10 years, as an example, where the other one is moving or something like that,
Yeah, so I'm glad you mentioned this, because this, my follow-up question is, are we today stuck regarding some hallmarks, or everything like is going smoothly? How's this seen? How are things going in general, let's say? High level image.
Yeah, to be honest, that's like such a loaded question, and the field is so huge that I don't want to give like a sweeping statement, but I can definitely say that things are moving. And to your other point, though, there are certain areas that are more challenging than others, and I'm just trying to scan through the roadmap to see if any of them just like jump out at me. But I'll just like point out one here, like telomere attrition, right? Like that's and again, I'm not a telomere scientist, so pardon me if I speak out of turn, anyone out there who is, but like, as I understand it, that's somewhat of a catch-22 and complicated one, right? Because it's not as simple as saying, oh, the telomere is shortened, so we just got to lengthen them, upregulate telomerase. Great. No, like, well, then that could cause cancer. So now like you're in like, so sometimes it's more complicated than just like developing a therapy to do something. Sometimes it's like, well, okay, well, this sits within a complicated scaffold, and now you have competing interests, and like it's all about how do you optimize this? How do you create a self-regulating system? So even still, just the notion of can we solve telomere attrition doesn't tell the full story, right?
So, and when it comes to Lifespan.io, are you also involved at the technical level in these companies? Are you spinning out to companies, or like what is the really like role or interaction between the organization and, let's say, that sector?
Yeah, good question. So historically, in the early days, we were focused solely kind of on the education and outreach and the PR side of things, right? But as time has gone on over the last 4 or 5 years, we've been gradually widening that sphere to include more of what you were saying. So as an example, what you might be familiar with, one area where we intersect with startup companies is we run the Longevity Investor Network, right? Which has monthly pitch meetings where our team kind of every month picks a couple of projects that are longevity related that we think would be good, and we put them in front of a group of longevity minded investors, right? Now, hitherto, that has been very kind of almost hands off from our perspective, in the sense of that, like, we're not directly involved. We're not running a syndicate or anything like that to participate in the deals. We're trying to figure out if there's something more codified that we can do there. But in that kind of informal matchmaking way, we've helped a lot of companies get invested and move to the next step. That is also one of the things that is hard to track, but we're trying to get better about it to improve our own value proposition to the public. Is very frequently, I might hear a message from someone who just got invested in their company, and they'll say, oh, we just wanted to thank you because our lead investor said that they fell down the rabbit hole of longevity research when they saw that Kurzgesagt video 7 years ago. So it's like the untracked value of the PR that makes the ground fertile for all of the investments and all that sort of stuff. So that there's that angle. And then in more of an operational sense, over the past couple of years, Lifespan has a little bit been more involved in a few different startups. So for example, Novos, which I had mentioned earlier, myself and Oliver in particular were involved in the early days of that company, helping to come up with the formulations and building the scientific advisory team. And as mentioned, Lifespan has a little bit of an interest in that company because of that. A similar example there is the Age Meter, which was out of the company Centers for Age Control, which is essentially a tablet-based physiological biomarker collection unit, right? That Lifespan also is similarly having an interest in. And then more and more recently, as of a year and a half ago, we have started actually doing our own in-house research projects, but very much trying not to duplicate the efforts of what everyone else is doing, of trying to analyze the field and like a military tactician, identifying like which projects are like overlooked and can have a outsized effect if they succeed. So the first example of this that you might have heard of is what we call the Mindset Project, which is basically organizing a first ever truly decentralized clinical trial for non-drug interventions for Alzheimer's disease that can sort of be done in crowdsource and an open source kind of way. And, this is based on, you might be familiar with combinations of stimuli like light and sound and transcranial electromagnetic stimulation. The nice part about that is because the therapy is digital in nature, and because typical diagnostics for cognitive decline are also digital, it creates an excellent first use case for something that you could truly decentralize. And to speak to the point of outsized effect is not only would it be wonderful if we can remediate dementia at all, if you look at it in the context of the backdrop of over the past 30 years in the US, over $1 trillion of taxpayer money going to traditional drug trials for Alzheimer's disease with almost zero results. If there was a new paradigm where just a bunch of people on the internet can put any kind of dent into Alzheimer's disease with non-drugs, that would be like an earthquake in terms of helping the system to kind of reevaluate like what exactly we're doing here.
Well, I'm really interested about this point because it joins what I I read some of the articles and papers talking about your interest in the blockchain and like decentralized technology. So you mentioned decentralized clinical trials, but what does that actually mean? And like, why the blockchain? Like, what are the role of blockchain in this?
So I'm glad you phrased it that way because they're kind of two separate but interlocking questions, right? So one of the main issues, like let's take Alzheimer's again. One of the things that slows the field down, in addition to just the traditional drug trials being very slow, expensive, is it's often kind of counterintuitively difficult to build up like trial cohorts because everyone's like competing for the same cohort. If you're taking this one drug, well, then you're not eligible for this other trial because of this and that, because you're trying to, in the traditional like gold standard double-blind placebo kind of trial mechanism, right? You're trying to wring as much statistical power out of a small cohort. So that's why you have to do it that way. So, but it makes it challenging and slow moving. So that's one aspect. And then also, little discussed, but philosophically interesting, it also violates like, Hippocrates do no harm. Because in the ancient Greek, like administering a placebo when you could administer a therapy is one of the harms you can do. So it's interesting to note that our system kind of builds in a violation of that because we're trying to wring as much statistical power. Now, with that as the current system, again, I totally understand why you need to do that if you have a limited cohort, right? So I'm not demonizing it. But if you had another way where you could structure a trial where you can get a cohort of 1 million people, well, then suddenly you don't need to play those same statistics games. You can get the statistical power out of a massive cohort size. And then instead, maybe you're varying the dosages or things like this, right? So you're not needing to give a placebo in that case, or especially with an Alzheimer's therapy we already know what the null hypothesis is, right? A straight decline into disaster, right? You don't really need to do a placebo in that case because you know what's going to happen if your people already have mild cognitive impairment, right? So my main point here on this decentralized clinical trial is that there's literally, without the blockchain component about it, just this idea of, are there ways to structure almost like combinatorial based trials that could leverage modern technologies that can allow the cohort sizes to be much larger so that you can present a different model for doing clinical trials. And then one note of optimism here is when I've had discussions with people in like the existing system of, hey, is this going to be okay if we do a clinical trial like this? I was expecting almost a pushback that would be like, well, you should really leave it up to the clinicians. You want this to happen, under the supervision of a clinician in a clinical trial center. But that's not really the reaction that I got at all. The reaction that I got was more like, oh no, this is really exciting. You should do this. We want to do this, but we're in like this calcified system that doesn't really allow for it. But if you essentially kind of embarrass us with a really great success, then that gives us the political will to be able to adapt. And, so I'm actually very optimistic. And basically, it's like, as long as you're, getting informed consent and you're like ticking all those like normal boxes, like there's no problem with structuring a more decentralized clinical trial. So that's the first part of the question, like decentralized clinical trials, what's the value, right? The second part, blockchain, where does that come in? Well, in some of these cases, I'm going to talk about a different project that I had worked on in the past that had to do with COVID-19 voice detection, right? Based on voice, right? Your audience can check this out. If you just Google like COVID voice detection, cough detection, you'll find like, oh, MIT is working on this, Stanford's working on that, company X, company Y. So like I was part of this work, I guess you can say, right? And one of the things I noticed, and this is what we'll bring back to the value proposition of blockchain technology, was I saw a lot of, I guess you could say, like shocking systemic failures that actually kind of scared me when at the time it was like 2020 at the height of the pandemic and like my friends are like dying. So like this was like serious, right? One of the things was that all of these different groups were working on very similar technologies. And number one, they didn't even know each other existed, which is already a problem. And number two, they're doing something slightly different, but that could have benefited each other. I'll give you a precise example. Maybe there's a team over here that's working on COVID voice detection, but it's a linguistic-based machine learning model, right? Because when you get brain fog and stuff, you speak a little bit more simply, right? Okay. And over here, you have a different group that's working on a frequency-based voice detection, because your vocal cord vibrations change, right? So the point here is they're each conducting their own kind of like mini clinical trials, and they're having people come in and speak in front of a microphone and say specific things so they can do their machine learning analysis. But they're collecting like 90% the same data set, but just slightly different with slightly different parameters. Where if instead there was like a single decentralized, apparatus where people were submitting their data set, and the data set had to conform to some maximal, collect. If you're doing any kind of voice-based detection of COVID, you must collect this data set. That data set could have then been amalgamated, and it would have strengthened each of their proprietary techniques. So it's a way that can help everyone work together in a smart way and in a way that doesn't unseat their own individual interests. And again, that also might seem like it's possible without blockchain technology. The area where it will become important is this kind of technology could make it so that a COVID voice detector could exist literally as part of your Apple phone. Just while you're talking, hey, did you know that you might have COVID? Like stay home, you talk to your doctor or something like that. But the roadblock to this is not technology. The roadblock is public comfort. Because people would be really, oh, is Big Brother listening to my voice, or like what's going on? So I think now you can see how this might intersect with some emerging, proof of human conversations and blockchain technology, things like zero knowledge proofs. Is there a way that I can prove that I'm an actual human being without proving which human being I am? Is there a way for operations to be conducted on my vocal data without my vocal data itself going to Mark Zuckerberg, etc.? And how all of this stuff can be tracked and provable on chain. This is maybe, it's going to take some time, but these are the structures that can enable this kind of comfort layer so that people can allow these sort of emergent technologies to exist. That was a little bit of a long-winded answer, but was that on target? Does that make sense?
That was very, very clear. So, are we talking about a solution that is currently under development, or the technology, like the blockchain technology, does not yet allow this type of solutions?
I would say that the technologies to house health data in a privacy preserving way is currently existing and emerging with a lot of different companies right now. So I'm just going to rattle off like five that just like jump into the top of my head. You have things like CureDAO, WeaveChain, Neural Technologies, Data Lake, etc. Right. So like this is almost like a hot area that's exploding right now. Right. And a good organization that I think is showing a successful model here in one specific aspect is Genomes DAO, which is basically, I believe, associated or spinning off of what George Church was doing with Nebula Genomics, which is, pardon me, Genomes guys, if I'm paraphrasing this incorrectly, but the way that I understood it years ago when I saw the pitch for Nebula was basically 23andMe on the blockchain where you own your data and you can choose who has access to it or sell it, etc.
Okay, so yeah, we are talking about, let's say, privacy preserving through blockchain and this decentralized technology. So in terms of like the other, let's say, big technology today is AI. So do you see like a role, or let's say an essential role to AI in the longevity research?
Yeah, absolutely. And it's not just like with like drug discovery platforms and stuff, which I think is probably the first area where people started to hear about AI and longevity kind of coming together, is in this notion of like platforms that were helping like assist with drug discovery and that sort of thing. But you said one of the magic phrases there, machine learning. That's really where I'm really optimistic, and where some of my own personal work at Lifespan and also in my my other capacity working in big tech has been centered around this idea of basically physiological biomarkers and how machine learning can really, really ramp these things up. As an example, we were just talking about COVID voice detection. These kind of voice modifications could also be a biomarker of aging, right? But like how you do that is machine learning models trained on voice data and this and that. So that is an example right there of machine learning. Other examples that I think are super important are things like walking gait analysis, right? Because walking gait disruption is something that happens as you age or with other diseases. Face analysis, right? Without naming names, but certain big companies, I'm sure you've seen how there's a exciting like de-aging and re-aging technology, right? But I think you can understand that if you're going to be able to do that properly, of course, implicit in the technology is an understanding of what it means to have a face of a certain age, right? So this is one of my longer term missions that I'm being a little bit circumspect here because I don't want to like say anything, but like, I work a lot in big tech. I also work in biotech. And from my vantage point, I can see that a lot of what biotech is struggling with right now, especially in terms of creating biomarkers, standardizing data collection, this kind of stuff. From my vantage point, I can see that a lot of these problems are already solved in the media world, and we literally just need to connect these dots together. So as an example, there's companies right now that are raising tens of millions of dollars to try to build like a walking gait analysis for aging, that are kind of just starting. But there are tech companies out there that can do like full skeletal body tracking of UFC fighters. Like that's like a decade ahead of that stuff. So we just have to connect the dots, right?
Exactly. So one thing I think of also when we talk about machine learning and AI is data, like the quantity of data that we have. So in your talk about like blockchain, decentralized technology, so this addresses part of the problem, like how to collect data without violating privacy. But also, like, do you think there will be, let's say, long years before we can collect enough data before we can talk about precision medicine or like more deep analysis of what causes, let's say, aging. Like we need to collect also much more genomes before we can be able to analyze um, causes of aging.
I think it's going to be different for every kind of sub area. Like genetic data might be different from voice data, might be different from body gait tracking, right? But again, I hesitate to prognosticate into detailed of a fashion. But again, this is something we have to be careful about so we don't trip ourselves into a Black Mirror kind of scenario, right? But I actually feel like we're very close um, to like much more adoption in this regard, and it's going to happen it doesn't happen linearly, right? It's like the tea kettle has been boiling, and like all of a sudden, like steam's going to start coming out. Like there's going to be some amazing use case. It could be, I'm making this up. I don't want this to happen, right? But what if COVID-20 happens, right? And all of a sudden there's like, hey, we solved it. You just got to install this. It's going to privacy preserve. There's an outbreak in your area. Just say yes, and we could tell you if you have it and stay home, right? Like some shocking use case that everyone would be like, oh, okay. And as long as the privacy stuff is absolutely assured, then like my point is that the second something like that happens, like the hurdle will just immediately get vaulted over, right? And then we'll be in a different world. Again, I think we have to be very careful about how that happens to make sure that we don't go into a scenario where it's super invasive and we lose our privacy and all that kind of stuff. So again, that's why to me, I don't want to be too controversial, but I think I have a little bit of credibility to say this, given that I've invented a number of like biomarker technologies and stuff myself, that I actually don't think the roadblock is technological. I think the roadblock is like in adoption and in like doing this the right way. Right. Yeah.
So how does it look like today for companies who want to start, let's say, a business in that sphere? Is it like, I mean, in terms of funding, is it like difficult to push new ideas, or like it's starting to be more like risk is more accepted? How's the scene looking?
Yeah. Complex answer, because I think the real answer here is just that the modes of fundraising are rapidly changing. So I think, for example, if you're trying to adhere to the older model of fundraising right now and you're a startup and you're trying to go to VCs and such, like in the normal way, you're probably having a pretty hard time right now, right? In the past couple of years. But if you are up on blockchain technologies, if you've become part of communities that are focused on funding public goods with novel funding mechanisms like Gitcoin, who I've been working with to help create some of these funding mechanisms, there is money out there for you. And more than that, communities out there for you. Assuming you're doing good things that are going to serve the public interest, which I think aging does, aging research does. Um, you know, Again, like Gitcoin is a great example, and there's a lot of other organizations like that that are trying to mobilize capital for these kind of, and longevity, is starting to become, dare I say it, hot in this regard. So I think that it is in a sense potentially less risky and easier to raise capital if you are flexible and keeping an open mind on these new ways of getting capital, in addition to the normal going to some, pitch to some normal VC fund kind of way. Do that too.
Yeah, so is Lifespan also invested in raising awareness about how, like, the ways for new entrepreneurs to, like, how to get to know about these methods, how to start out a business in that sphere?
Yes, this is one of the key areas that's sort of becoming like a new emerging tentpole of our work. So I had mentioned earlier that it's like public education and outreach was like the first and one of the largest operations that we conduct. The second is identifying these like critical research projects that could have maximal effect, like the Mindset Project. And this is the third one that you're talking about now. This, educating and involving the public in like, a crowdsourcing kind of way of getting involved in these new public goods funding, philanthropic mechanisms, and some of these. And I'm about to become more public with this, and I might talk about this at our Lifespan.io conference that's going to be happening August 10th and 11th, because I've been spending kind of the last couple of years kind of working with a lot of the different pioneers in the blockchain technology space, especially in the crypto philanthropy intersection, to actually create like new funding models using like decentralized finance and also like GameFi to do very interesting things to raise money for public goods. With obviously, because of who I am, the first public good that I want to start with is aging research, like cause-based funding for the field of longevity in a way that's like self-renewing and exciting and has like great hooks for the public to be involved in. Because I'm being a little vague, I'll be specific in one or two examples. One is this model that I've been putting forth that I call proof of philanthropy. There's a lot of different proof ofs in blockchain technology, proof of stake, proof of work. So what I'm calling proof of philanthropy is a new novel kind of dynamic NFT that actually scales up and down in its power and its aesthetics based on your tracked on-chain philanthropic giving to a cause like longevity. So this can trigger a lot of interesting ways to do like interesting follow-on funding that I won't have to describe, but like take that and then have the output point of that funding be something that is self-renewing and self-investing, like the same way like a college's endowment works. And together you can create a model that is like self-perpetuating and funding and like building up capital that can then fund the field kind of forever in the future. And also, if you want to get clever with it, you can also do more complicated things like, well, maybe those NFT holders can comprise like a voting DAO that can also vote on how the output of that model disperses to different things. So that might be a little bit complicated. So I will switch to a more simple one that I think was easier to understand. I've been personally working with some of the largest blockchain gaming companies, probably about to announce publicly soon in partnership with Lifespan, to create a massive game that would, through its operations, raise funds for aging research just as a natural consequence of the game mechanics, where the game itself is thematically focused on a metaphor for aging, the fable of the dragon tyrant, if you're familiar with that. So a lot of people are trying to kill the dragon tyrant in the game,
Wow.
doing interesting game economic stuff, and then the money is actually going to the organizations that are working on slaying the dragon tyrant aging in real life. So this is an example of kind of combining public outreach and funding, and then also decentralized science. So I see you have a question, but I'll describe how the decentralized science aspect could factor into that as well after.
No, that was just a comment. I've been always fascinated with the concept of like playing and the outcome is like really useful, like helpful and like impactful. So I'm really glad and very enthusiastic about any game of that kind if you announce it on your site in the future. So back to what you were. Sorry. Go ahead.
Yeah, so I was just going to follow up by saying, so you can already see how it's already kind of cool and potentially transformative to pair like, an Axie Infinity size game, but that's actually doing like real world utility to help save all our lives. Like that's already like a great narrative and cool. But then if we tie this back to things that we were talking about earlier, like potential interesting therapies that involve light and sound and things like this, there are potential upgrades to that game idea. I don't want to get too complicated, so this will be like phase 2 or phase 3. Let's let the game become successful first, right? But you could see how maybe as you go deeper down the dungeon and get closer to defeating the dragon tyrant, maybe the actual aesthetics of the game take on some of these potentially therapeutic stimulation properties. And then if you only did that for half of the cohort and you gave a sham stimulus for the other half of the cohort, and because a video game naturally can track things like decision-making speed and things like that longitudinally, you can almost maybe structure a massive decentralized clinical trial through a video game, which would be, I've never heard of anything like that. And I think it's eminently doable. Yeah.
That would be fascinating to have. Okay, so let's move to some questions about social impacts of aging, of let's say living a significantly longer time than what we know today. So many people talk about equality. So rich people are going to live longer, and poor people are going just to die very young. What's your response on this?
Yeah, I think this is actually a very important question or issue to address, because this is one of those emerging kind of anti-narratives that I see right now. A story might happen and go, oh, look at this rich billionaire trying to live forever and like siphoning our life, like the Blood Boys and all that kind of stuff. So I think this is actually a very important question to address and sort of get ahead of, so that negative narrative doesn't take hold. So first of all, I will say that even if it does happen in certain cases, even if that were to happen with like rich people first, I believe that the technology will make its way to the public very rapidly, kind of similar to what happened with cell phones and stuff. How almost everyone has a cell phone, right? But that being said, the way that I prefer to kind of counter that narrative is like, this is why it's super important to lean forward into the ideas of decentralized science and crowdfunding and crowdsourcing, because you don't need to worry about things trickling down if they actually come from the bottom up. If we do a decentralized clinical trial for an anti-aging therapy with the public together for free, or maybe we're even giving them some cryptocurrency for their effort, etc., you're now doing it from, and also another good positive side effect of that is there's a crisis of trust right now in the institutions, right? So I believe that the public would be much more accepting of a potential therapy that they actually helped to make themselves, and they fully understand because they were actually the ones doing it, right? So that's my answer to that question. And I think that there is now a great flowering in this idea of people seeing the value of, whether it's paired to blockchain or not. Sometimes it is, sometimes it isn't. But this idea of open science, decentralized science, there's a long pedigree there, going back to other movements, like just in general, open science, citizen science, like GenSpace that I mentioned earlier, things like Sci-Hub with Alexander Alcaban, trying to open source access to scientific information. I think this is a battle that's being won in that the public is seeing the value, or that it's important to prioritize this open access, open ability for people to participate in the scientific process. And I think that aging research, especially since some of the aspects of it might involve quote unquote simple physiological things like we were mentioning earlier, it's a great opportunity for us to say, don't worry about what those rich billionaires are doing. Let's do this together.
Okay, so let's say on the longer term, there might not be risk for inequality, but do you think that it could start out in an unequal way? Like in its first years, let's say, when the solutions start to be rolled out, be like richer people will get hold on it first. Like, let's say for several decades, like 100 years, they will be living longer until it's democratized.
I think it's possible, but I don't think it's likely. And I think the important thing to underline here is that it's very much a societal decision that we have a role to play in. So as you may or may not be aware, there's now a longevity caucus in Congress that is an outgrowth of the work of the Alliance for Longevity Initiatives that we also have collaborated with at lifespan.io. There's initiatives like ARPA-H that are focusing on aging. And, a lot of my point is that it's very possible that because of things like the demographic crises that might cause significant problems for Social Security and things like that in the future, that there's legislation and funding priorities that are going to be coming up in the next decade that are going to determine this. So I think if we can I think there's an ability for us to ride along the successes of the past with certain like disease funding or disease prioritization, or what should be insured or not, or what should be part of the base level care for a citizen of a country. And that's kind of in flux right now. I think America, needs to do a little bit of a better job right now in terms of what is the base level of care that is conferred to the average citizen. But the point is that I think these conversations are going to be happening in the next couple of years, and there is definitely a lane for us to position that, preventative care should be something that is fully paid for an average citizen, because it's going to pay, this is the longevity dividend idea, because it's going to save a lot of money on the government side. So I think that to me, as just someone who looks at data, it's logical that we should do that as a society. Now, whether there's political considerations or not, that's what I can't predict. But I guess what I'm trying to say is that I'm optimistic that if we play our cards right, we can make this something that by design gets conferred to the average person in the public.
And this completely makes sense, because if we think about other in history, I mean, about vaccination, like the solutions that radically changed the average lifespan of people, it's now completely like available to the general public, because there's this benefit, and in terms of let's say insurance companies and like governments and demographics, economic problems. So my last questions here is about a point like, let's say, a reflection I read about from Elon Musk. So when he was asked about longevity, he expressed kind of uninterest in his disinterest in the idea in terms of how people will be responsive to innovation and new ideas. So in his opinion, older people tend to be more resistant to innovation, to new ideas, and to, let's say, creativity and change. So a society where there are many old people will be a society with less innovation and more resistance to new idea. What's your response on this?
Yeah, thank you for asking this. Unfortunately, I think this is a very short-sighted take from Elon that's not substantiated by actual data that I'll get into, and has some critical assumptions that are baked into it. And, if I ever get the chance, I'd be happy to engage Elon in a thoughtful dialogue about it. But just to address some of it right off the bat, for example, analyses have shown that on average, like, most of the great inventions and breakthroughs that have happened throughout history came to those later in their life. So I think just part of the premise is incorrect. Like data shows that, people who are older can be very innovative. Now, maybe he's speaking more to like the average person in society and their reception to it. Maybe that's a slightly different question. But furthermore, here's the more important issue, I think. Even if Elon's assumption was true there, why should we make the additional assumption that it would have anything to do with the number of years you've walked the earth, rather than, say, a potential loss of neuroplasticity due to aging as it currently is, which is something that we would need to solve if we're successful in combating aging. So I actually think that even if it was true, that speaks to exactly the work that, like, I'm a sample size of one, but for me, lastly, I find the take just very depressing, because I personally feel that with longer and healthier lifespans, people would have the chance to become more wise, more curious, and dare I say it, more compassionate and creative, if they had all of their faculties coupled with the experiences of time and the time to experience more wonders in the world. So, like, I just imagine that as long as you're healthy and not in pain and curious, you're going to be more inspired and be able to make more connections. Like my example with Tesla before, right? Unintentional connection there. To use Tesla to address Elon, I believe if Nikola Tesla had 5 more healthy years and his brain was functioning dandily, who knows what he would have done. And that's just one person. I don't mean to pick one person. I think that apply that to every human being on the planet. So that's how I would engage Elon. I'd be happy to have a conversation about it. I just think it's not a great take. Sorry, Elon.
Yeah. And I think it's really interesting to think about longevity as it might change our definition of what's young, what's receptive to new ideas, in terms of really like the healthy or the young substrate, let's say. A younger substrate might change radically the way we interact with the outside world and to the new generation. So I'm really fascinated by this.
I just thought of something random. Sorry if we were done with the question, but this is a different, it's an analogy in the physical realm. I think I had mentioned earlier that I had studied and taught martial arts and yoga for many years, right? So one of the things that I've done there is study the softer styles, things like Tai Chi and Aikido versus the harder styles, specifically because you don't lose those as quickly with age. If you're studying a hard, Muay Thai or something like that, you're a devastating fighter for 5 years, but then you become crippled because you've done so much damage to your body, right? Where the softer styles are not like that. But still, as I'm getting older, again, I'm 44, when I'm doing my forms, when I'm practicing Tai Chi, I have to be much more careful, because if I am lax with my form, if I do it incorrectly, I will hurt myself in a way that I would not have when I was younger. So a thought that I've had to myself, which is somewhat related to the earlier conversation, is, wow, if I could now take this care that I've had to cultivate because I'm older, but then suddenly have the body of a 20-year-old, what kind of fighter would I be then? Like, you know what I mean? Like, so I think that's interesting.
Totally makes sense. So yeah, it's interesting and very important also when we think about longevity to think about all the details and the change that might not be evident actually at first glance that this could make to our organism and also to our mind. So yeah, like actually my next question is like what people who are listening to you can help actually or do or like some actions to take. So I think one part of the answer is to maybe check what's happening here in lifespan.io. I think you have all of these what you are talking about on your website, right?
Absolutely. So yeah, I would say the first thing that people can do to help is, get educated, learn the latest. Go to lifespan.io, sign up on our newsletter. We're on every social media. I think we're pretty much, slash lifespan.io or lifespan.io on, most of the social medias. We have a Discord server, all that kind of stuff. As mentioned earlier, we have a variety of YouTube channels that kind of hit all the different areas of, wide public to narrow focus. And the widest one is a channel called Life Noggin, which is a science animated educational content that's very accessible, has over 3 million subscribers. Yeah. And I would say just in addition to that, becoming part of our community, the two big ways that anyone can help are, somewhat obvious, but I'll say them. Number one, donations if you can, or connecting us with people who could support us, who could sponsor our conference that I had mentioned, sponsor a Life Noggin video, just straight up donate. Crypto is acceptable, lifespan.io/crypto. And also a lot of these projects, they require people's, actual help. Are you good with social media? Can you help share our stuff? Are you an excellent smart contract engineer? And are you interested in anything we just say? Like, there's not enough people to go around in terms of actually building things. There's a lot of people talking, but not enough, in my opinion, builders. So if anything that we've talked about in this conversation speaks to you, reach out to us. You can find the contact points on our website. You can reach out to myself or our executive director, Stephanie Danow, that you could find. Yeah, and come to our conference in August 10th and 11th. I think that should be up on Eventbrite now. Yeah, and the last thing that I'll say on this or last two things is where I've been successful in the past for convincing all walks of life to support our work in particular, even if the person that I'm talking to is not necessarily even sold on the fact that they care about aging, is that whatever you care about, if you care about climate change, if you care about existential risks, whatever it is, this one simple fact: the average human being is going to spend the last few years of their life in significant cognitive decline. So if you help us solve that problem, through the Mindset Project or something like that, you will literally give every scientist working on whatever you care about maybe 5 more healthy years to solve that problem. And if you look as an example, like take Nikola Tesla, he was just one person, right? But I personally think that he was probably close to like wireless electricity for the world, but he had some significant health issues and went down in decline the last couple of years of his life. If that one person had 5 more healthy years, literally the entire world might be different. And that's just one person. So apply that to every scientist for whatever it is you care about. So if you're looking for, I know it's a little bit of a dirty term now because of Sam Bankman-Fried, but if you're looking for real effective altruism, I think this is like that critical thing in terms of all human endeavors. And the value, the compounding force multiplying value of inspirational PR projects is often overlooked. That Course Kazakh series I mentioned was a couple of tens of thousands of dollars it cost us, but I think it's fair to say that that brought in like tens or more millions of dollars into the field, in addition to people and excitement and press and all that kind of stuff. So support us if you can. I think it's massively valuable. And the last thing that I'll say is every second somebody dies of aging. That's 1 second, one life. So what that means, that's depressing. But on the flip side, that means if you out there get involved in any of the ways that I mentioned, whether you help us or help another organization in the field, if whatever you do does nothing but speed up the pace of some of these therapies arriving by 1 second, you will have saved somebody's life.
Yeah, thank you very much for this very clear answer. So I think, like earlier we said, like the one of the few things we can do to increase our health span is to do sports and like eat properly. But I think this is also an answer. If technology is not yet there, we can also be up to date and support. And I'm really glad there's that platform Lifespan.io, because we really like there are many information out there to get updated and to track what's happening, and also to be able to concretely help actually, and through the roadmap to track also the results, what's happening here in terms of breakthroughs and advancing technology. So yeah, on this, thank you very much, Keith Comito. That was a great and inspiring discussion, full of very helpful and insightful information.
Great. Thanks for having me. Hope the audience enjoys it, and I'd be happy to have a follow-up anytime you like.
Thank you very much.